Bueno, pues buenas tardes. Buenas tardes aquí en España, buenos días en Sudamérica, en Latinoamérica, aquellos que nos escucháis en Latinoamérica. Bienvenidos a un nuevo webinar de los organizados por la red de portales it-latino.net, it-spain.net, webinars gratuitos, formativos e informativos sobre las diferentes líneas tecnológicas que tratamos en nuestros múltiples portales. Os recuerdo cómo es el formato de este webinar de hoy. Durante unos 45 minutos el ponente hará su presentación, en este caso la presentación es en inglés, y posteriormente pasaremos a un turno de preguntas. Las preguntas podéis plantearlas vía voz IP, para lo cual necesito que levantéis la mano accionando el botón que pone Raise Your Hand en inglés en el panel de control de GoToWebinar, y yo os abriré el micrófono, bueno, y os escucharemos tal cual me estáis escuchando a mí. También podéis hacer las preguntas, bueno, escribiéndolas donde pone questions, y yo se las trasladaré al ponente. Recordaros que el webinar se está grabando, se graba en su integridad y se publica en nuestra red de portales, en demosdesoftware.com, que es nuestro repositorio de webinars grabados. Ahí tenemos más de 1100 webinars grabados en la actualidad, y podréis ver el webinar por capítulos, con lo cual bueno, pues podéis ver la parte del webinar o las partes del webinar que más os interese. Los webinars se pueden ver tanto en iPad como en tablets Android, con lo cual podéis consultar cuando más os convenga y desde donde más os convenga la grabación de los vídeos. En el día de hoy vamos a hablar, bueno, pues de un tema que se mete más en la parte de telecomunicaciones, en la parte de protocolos de telecomunicaciones en Internet. Vamos a hablar de IPv6. Yo creo que es un término que mucha audiencia corporativa pues no conoce del todo bien, ni lo que es, ni cuáles son las posibilidades que ofrece, ni, por supuesto, cuáles son los caminos para migrar a ellos, ¿no? Esto tiene un gran interés, pues, sobre todo para son carriers de telecomunicaciones, proveedores de telecomunicaciones y de Internet. Seguro que muchos de los que estáis siguiéndonos pues pertenecéis a este tipo de empresas. Bueno, con nosotros tenemos, hoy tenemos un webinar en inglés, ya os lo advierto, creo que ya lo conocíais. Tenemos a Steve Sacci, que es Product Marketing Manager de A10 Networks, una empresa que ofrece productos para facilitar la migración a IPv6. Steve nos está hablando desde Nueva York. Le voy a hablar, le voy a abrir el micrófono. Steve, do you hear me? Do you hear me? Okay.
I hear you fine.
I will pass you now presentation.
Great.
When I see the presentation, I will say to you. Okay, we see your computer. When you want, you can start.
Okay, so you can see the whole full screen now?
Yes, perfect.
Okay, great. Well, first of all, thank you very much for allowing me to present to all of you. Now, like you said, I'm located in New York City, so good morning for me, but maybe good afternoon for those in Spain, and if anybody's joining from South America, I assume it's good morning as well. So I think I have all my time locations correct. But anyhow, like I said, I'm with A10 Networks. I'm a product marketing manager here. Previous to that, I was a systems engineer here for 6 years. So I have a lot of experience around IPv6 and IPv6 migration implementations as we do it. So today's presentation, we're going to basically go through a lot of the migration technologies used for companies such as carriers and large enterprises on how they would migrate from IPv4 to IPv6 using some of our technology, but also going through some of the standard technologies that are available out there. So with that, let me give you a very brief overview of A10 Networks for those of you who don't know. So first of all, we're a technology leader in application networking. We have products that range everywhere from a couple of gig all the way up to 40 gig and above beyond 100 gig. We were founded in 2004 by a gentleman by the name of Lee Chen. You may not know his name, but you're probably familiar with some of the companies that he's founded. He actually founded a company called Foundry Networks, which is one of the largest networking companies out there, which was also recently purchased a couple of years ago by Brocade. He also founded a company called Centillion Networks before that, both very successful companies. We're headquartered in San Jose, California. We have offices in over 15 countries worldwide. I think that might even be larger, that number now. And I think the number is about 430 employees that we have worldwide and growing. We're very profitable, consistent revenue growth from quarter to quarter. And our flagship product family is the AX series, which I'll get into within the presentation here. So, of course, just for a quick review, for those of you who don't know, some of the benefits of IPv6. Of course, the biggest problem is IPv4 address abundance. As you know, IPv4 addresses are pretty much almost out, if you would, and the availability in IPv4 address is very difficult unless you want to purchase it. And you can see the IPv4 address blocks that are available have been reduced pretty significantly. AT&T added 1.6, just to give you a little blurb, 1.6 million non-phone wireless devices in Q1 of 2011, and now that passes about 12 million devices. So what does IPv6 bring? Of course, the added amount of addresses is probably the biggest thing, right? The ability to have millions upon billions of addresses. Its efficiency, once again, IPv6 is now optimized by routers and other IPv6 devices such as cell phones and pretty much anything that has an IP address nowadays. As you can see, most of the devices there are consumer-oriented type devices, but that's kind of really driving the amount of IPv6, the drive to IPv6 addresses. Of course, down there's some mathematics which kind of show you, the number of IPv4 addresses available and number of IPv6 addresses available. So obviously, the higher number is really the most significant thing. Okay, so once again, everybody knows there's massive acceleration and growth. Microsoft recently to acquire Nortel's IPv4 addresses for $7.5 million. So as you can see, addresses, I think, range from about $9 to about $12 nowadays per IP address. We know several cable companies and so on have bought up as many IPv4 addresses as they can, but as time goes on, that'll be certainly diminished. So the key point here is that once again, for these type of carrier companies and enterprise companies that need to continue to add services, they're going to need to have either go native IPv6 or have some kind of migration technology that takes them from IPv4 to IPv6. Okay, so what are the two main drivers for migrating to IPv6? The biggest one, of course, is IPv4 exhaustion, just like I mentioned. The fact that we're running out of IPv4 addresses, not such a big deal on the consumer side, but obviously a very large deal for any kind of service provider who needs to grow and continue to expand. And of course, the second one is adding IPv6 services to legacy IPv4 infrastructure, meaning companies that want to offer IPv6 services but don't necessarily want to change their internal IPv4 infrastructure considerably is driving them to use the IPv4 to IPv6 migration technologies. Okay, so of course, we have an IPv4 network, an IPv6 network. There's no standard compatibility between the two. So how do we migrate these two together? And there's different requirements. Of course, for the home, any home user or cable TV user, they really don't care too much. They just need to know they can gain access to the Internet as it stands today. So they have some very specific requirements, typically usually driven by whatever cable provider or Internet provider is servicing their home. Enterprises, large companies, not such a big drive to go to IPv6 if they have a very large IPv4 infrastructure, but their requirements basically mean that they need to have some kind of migration technology or conversion technology, right, to go. So if they're they need to provide their customers IPv6 services. They need to get to all of their services which are existing IPv4. They need that migration. And of course, the service provider, his biggest requirement is the ability to continually add public addresses, right, private addresses to meet the demand. The biggest one, of course, is the smartphone, cellular phone market, where they have literally millions and millions of users every day being added and so on. And basically, they don't have enough addresses to support demand, so therefore they need to supply IPv6 addresses for new devices and so on. Okay. So what are some of the technologies available out there for IPv4 to IPv6 migration? Of course, we're showing in the middle there is one of our products, the AX series, which I'll get into a little bit later. But it's in this case, it's a migration gateway, IPv6 migration gateway. So there's a lot of acronyms up there, which I'll go through each of them. LSN, which stands for large-scale NAT. So NAT network address translation from IPv4 to IPv6, 6 to 4, and so on. NAT 6.4, that just means network address translation from IPv6 to IPv4. DNS 64 also goes along with that, which we'll describe in a little greater detail. DS Lite stands for dual stack light, 6RD for 6 rapid deployment. Once again, those two are very specific to cable TV, home use, those kind of areas. 6 to 4 and SLB-PT. These are enterprise-related migration technologies. Each of these, don't worry about the acronyms. I'll explain them deeper as we get deeper into the presentation. But this kind of just gives you an idea of all the different things covered. You'll notice on the left there in the picture, IPv4 clients coming into the cloud, IPv6 clients, combination of the two coming into the cloud, and these all need to get converted to access both the IPv4 and IPv6 internet. Okay, so here's the different migration technologies and kind of generalizing them how they work. Of course, if you were doing it, you needed to build a dual stack environment, meaning that you would have routers and switches that support IPv4 for one particular network, and then a whole duplicate of others that switches and routers that support IPv6. That's fine. Some companies have done that, but obviously that's very expensive, and now you're managing 2 networks. So it's not as easy to do. Encapsulation. So these are some of the other technologies where I would basically take an IPv6 packet and encapsulate it into an IPv4 packet so that it can ride an IPv4 network. And then, of course, the reverse, an IPv4 packet within an IPv6 packet. And then, of course, the last one, which is probably the most useful one, the most easy to implement, is the translation from IPv4 to IPv6 and vice versa. Okay, so let me go through some of the individual technologies here. So, of course, DS Lite, which stands for Dual Stack Light, and that's used in combination with network address technologies like large-scale NAT and carrier-grade NAT, which I'll go into a little bit deeper as we go. So Dual Stack Light, this is really designed, it was designed with the cable modem home user in mind, meaning that a home user needs to has legacy IPv4 devices such as PCs and gaming and so on, but that needs to ride on an IPv6 network that the cable provider has. So what this means is that you'll have to have a CPE gear, right, customer prem equipment that's like a Linksys router or a Netgear router, some device that has this DS Lite technology riding on it that really is nothing more than an encapsulation technology. So it takes in an IPv4 packet, converts it, and puts it across an IPv6 tunnel, as you'll see in the diagram there. It then may hit a large-scale NAT gateway device, such as our AX series product, and allow the traffic to then propagate through the service provider's IPv6 network, and of course onto their IPv4 internet to get to various IPv6 or IPv4 services. So we kind of show it 2 ways there if you look down the bottom. So the usage really is provided by ISPs to allow home users access to their network, to their IPv6 core network. So some ISPs, some ISPs are combining DS Lite where they provide to the customer, and then internal in their own network they will use services such as DNS 64 and NAT 64, which I'll talk about more specifically. 6RD is also another version, another encapsulation type technology, which once again, it does the same function where it will sit on the customer's prem device, which will have this technology loaded on a various CPE type device, and it will take IPv4 type excuse me, IPv4 packets and introduce them and open up a tunneled connection into the IPv4 cloud, and then that will also hit once again a IPv4 or IPv6 migration device, such as our AX series product. And once again, this is used by ISPs. It's also been it's been tested, but in very few few ISPs, because obviously they don't want to force. The negative part of this is that carriers and cable providers don't want to force their customers to have to add more equipment or upgrade equipment and so on. It just makes the transition more difficult. So with that, before I go into the NATing technologies, let me just give you just kind of a brief overview of what NAT is for those. So, of course, NAT stands for Network Address Translation. So if you look at the numbers over there, if I'm from a specific source, an IPv4 source in this example here, and my destination is the 186 number, and I need to convert that from the inside to the outside, as you see, and I need to supply a source that is, I need to convert it to a source that's a public IPv4 address, and then hitting another, to ultimately get to that destination. Now, NAT has been around for a long time, and we use it, in our home. Routers use it within the networks, but NAT is very different from what we consider carrier-grade NAT. Okay, so traditional NAT has significant limitations. First of all, it's not scalable. The ability to handle, millions and millions of addresses and translations very, very quickly is just not available. The bigger part of that is that there's really no ALG's application level gateway support for standard NAT. And this really comes into play where, for instance, customers getting into a network, like when you NAT from your home out, okay, a carrier doing that same NATing now needs to allow it to be totally transparent regardless of what type of application you're running. So whether you're doing gaming, peer-to-peer, which traditionally breaks using traditional NAT, voice over IP, or any kind of streaming protocols, very difficult to do that with regular NAT. Actually, you can't do it with regular NAT. Other limitations are things like there's no user quotas, the ability to provision it accordingly, meaning allowing customers to open up a certain number of ports, but not to just take advantage and actually create kind of an overload where they're taking too many ports, right? So there's some limitations and controls there. And of course, logging. Whenever you're doing any kind of NATing, from a service provider perspective, they need to be able to keep track and log all these different NAT translations in the event that they are asked by the government to go back and find out who an individual user was, whether it was somebody who they're trying to find or tap or what have you. So these are all limitations that traditional NAT does not have. Another misconception out there is that traditional NAT supports, if it supports a large number of connections, it's considered carrier grade. That's not true at all. It just means that they can do traditional NAT, they can handle a large number of connections, but that's not what we consider carrier grade NAT or large-scale NAT. So, moving on, large-scale NAT, or what it's also known as, aka carrier-grade NAT. So you may see both terms. Traditionally, carrier-grade NAT is kind of, I believe, is the standard, I shouldn't say the standard term, but the term that's used out there in the public. And large-scale NAT is typically a term that's used by individual vendors. But either way, it means the same thing. And then the term NAT 444, which that really means a network address translation for translating for twice. So if you look down on the bottom part of this diagram, you'll notice like a user, a home user with an IPv4 address, then he gets NATed network address translated to, like, say, his own personal CPE device or cable modem, and then when it gets inside the cloud of the service provider, it gets NATed again to the public IP4 address. So that's hence the term NAT 444. Okay, so if you look at this, this is probably the most easy concept for a service provider, meaning they don't have to load the customer, their home user customers up with specific software, meaning in the case of DS Lite and 6RD. In this case, the customer uses the same router that he's been using all along that will NAT him from his private home IP address to the public address of the service provider. And then within the service provider, they will do another NAT translation using, like in our case, our AX platform to then convert the, to do another network address translation out to the services where they need to get out to the internet. So once again, this is typically used by ISPs. More and more ISPs are taking advantage of this, so we currently to date have quite a few customers, both service providers, wireless, or I should say cellular service providers, also using this technology. So the key here is that it has a very large IPv4 address capacity. The goal here is to take a lot of IPv4 addresses and consolidate them into a smaller number of addresses, a fraction of addresses. So this helps them deal with the IPv4 exhaustion problem, right? So meaning that an IP, if a service provider only has a limited number of IP addresses as well, so in order for him to efficiently utilize those addresses he has, the large-scale NAT allows that large number of addresses to be reduced to a smaller number of addresses, so they can support a lot more users and continue to grow. It also provides a very scalable logging mechanism. What that means is now that the service provider is doing that, he needs to account for all that. So we also have technology that allows us to stream that logging information, or I should say distribute that logging information to logging collecting devices. So it gets compressed and it doesn't take up a lot of space, because if you're doing logging for millions and millions of customers, that could take up a lot of storage. So we have some technology specifically designed for logging that helps reduce that amount and the amount of logging storage that's necessary. So we can get into that offline if anybody out there is interested. So of course, in my previous diagram here, where we was just specifically speaking of IPv4 addresses being added to other IPv4 addresses. In NAT 6.4, or Network Address Translation 6.4, what that now means is that we're now taking IPv6 addresses and now translating those into IPv4 addresses to, once again, to provide an IPv6 service. And the service providers that are interested in this, of course, are MNOs and ISPs, and of course enterprise customers who are now looking to allow IPv6 technology, or I should say allow IPv6 services onto their enterprise network. So you'll notice over here in the example we show, we have a sort of a new cell phone or PDA user. Okay, he's using an IPv6 address. He basically needs to get to an IPv4 service through the IPv4 internet. So by having our AX device here, which is the gateway device, it will now take in the IPv6 address, translate it to a public IPv4 address, and then switch it along to the service that they're trying to get to. Now, another component of that, of course, is another piece of technology that goes hand in hand with that, which is DNS64, meaning they're trying to get to a service on an IPv4 network, and they're doing an IPv6 DNS request. So there needs to be some kind of conversion in order to accommodate that. So if you look down on the second half of the diagram here, you'll notice that a DNS, or what they call a quad, a DNS query goes out, and then what the AX platform will do using DNS64 will then generate both an IPv4 DNS query and an IPv6 DNS query. And then, of course, only the IPv4 response is going to be on the return, excuse me, and therefore the user is now connected to that IPv4 service. So, of course, the goal here is to provide IPv4 content with access for IPv6 only clients, and of course this is going to improve their migration very easily, because now all of the IPv4 content and access they need to get to can now be provided to new IPv6 users. Okay. Another technology, now this one, like I said, is still typically used in service providers, even though it says enterprises. There's a small amount of enterprises and may potentially use it. What enterprises would probably most likely use is something called Server Load Balancing PT, or SLB-PT. And you can see it's got two names there, SLB-PT or SLB-64. PT stands for the port translation, and 64 obviously stands for going from 6 to 4. So if you look on the upper diagrams, you'll notice that if we're going from right to left, under the enterprise portion of the diagram you see there, you'll notice that the enterprise's infrastructure is all IPv4. And the IPv servers, IPv4 switches, routers, and so on. But now they want to offer an IPv6 service to their customers who may need them, whether those are international clients or they just want to offer those services. So you'll notice the IPv4 internet and the IPv6 internet both hitting the same AX series device. Now for the IPv4 portion of it, we'll do something which is just standard load balancing or standard port translation. Meaning it'll come into an IPv4 address, and that will be translated into an IPv4 address in the back end. On the upper part, or the orange part of the diagram, these will be IPv6 users coming into through the IPv6 internet or some IPv6 infrastructure, hit the AX device, and the SLB technology will now, if you look down on the bottom part of the diagram, you'll notice that the destination IPvIP or IPv6 address is now translated to an IPv4 address and to hit those IPv4 address servers through their IPv4 infrastructure. So the AX device will take care of all the port conversions necessary in order to provide that totally transparently to the user. So once again, the goal here is to offer IPv6 services very quickly with minimum changes. So once again, as a enterprise provider, you don't have to go and change anything on your infrastructure on the IPv4 side. You just need to provide an IPv6 address, public address to the outside world, and you will now be able to provide IPv6 services. Once again, that's SLB-PT. So I wanted to give you a couple of examples of some actual real customers. So here's a little bit more detail of a cellular customer, excuse me, one of our large cellular customers. So they had this problem. A lot of their legacy, one of the largest cellular providers here in the United States had the problem that they didn't have enough IPv4 addresses to keep up with their existing legacy devices that were out there. In this case, smartphones, PDAs, tablets, and so on. So if you notice there on the left, we're kind of showing the cell towers and all the PDA devices and the number or thousands and thousands of IPv4 addresses, actually millions of IPv4 addresses that are being generated. But in this example, those come through the mobile provider's private IPv4 network. They then get consolidated to a public IPv4 address. So in this case, we could literally take thousands of IPv4 users with individual private IP addresses and now NAT them to a single IPv4 address. So therefore, this allows the carrier to now preserve his IPv4 addresses. So therefore, he doesn't overload, or I should say, run out of IPv4 addresses. So he maintains, he can continue to scale his network, but he will not run out of IPv4 addresses for his existing environment. So the technology used in this case is large-scale NAT 444. So if you look, you'll see that, for instance, PDA users will go through their own network address translation once, and then through the AX series product will also get NATed again, hence the term large-scale NAT 444. Along with this, there's a lot of other technologies that they use in the background. They have to use the logging technology that we have so that they can keep track of all of these network address translations in case they have to go back and find out who the individual user was, and the ability to support millions and millions of these translations at a very high rate. So the performance of the AX device is designed to keep up with that very high rate. And I'll describe that a little bit later on as we go through. Also, another part of that was, in my previous slide, I just described IPv4 to IPv4. Now, in this example here, we're showing where their newer devices now will use IPv6 addresses, but they still need to be converted to IPv4 in order to gain access to IPv4 services. So in this case, those devices will ride and get their IPv6 addresses from the mobile carrier's IPv6 network. They will then hit the AX series and then get translated to an IPv4 address using NAT 6.4 and DNS 6.4. As you can see, once again, the goal here is to provide IPv6 services, but reduce the amount of addresses that are required by the provider. Okay. Last one I'll mention here is kind of a pure IPv6 to IPv6 customer, NTT Plala, in Japan, which they've been running this since live, and they went live in 2008, Kari TV, which the purpose was a large IPTV broadcasting and video on demand service. It's native IPv6 based, fiber to the home based. So it was the first large scale commercially successful application of IPv6 services. And then you can see a little quote down there below. After many comparative tests, they selected A10 network services for their IPv6 high performance server load balancing network to provide IPTV, just real name there. And this is kind of a little bit more about them. So the IPv6 access for all customers in the systems. The purpose really was to allow IPv6 for all of their Asian partners. In this case, they were providing dual stack where they were running both IPv4 and IPv6 connectivity across the same platform. So in our case, our single AX could support both IPv4 and IPv6 totally independently. So if they wanted to run dual stack, meaning running two separate networks, that's fully capable on the A10 load balancer. I'm going past that one. Okay. So now IPv6 is now getting mature. As you know, there's worldwide interest. Many governments, including the U.S. and the U.K., and several other governments, of course, have mandated that all new installations support IPv6. There's many IPv6 certifications. So this kind of means that things are being utilized more and more. And of course, it's going to take several years for IPv6 to be more widely used than IPv4. But of course, the migration has started pretty significantly. One note, one highlight: we were actually part of IPv6 World Day. So we used a variety of IPv6 load balancing and SLB-PT conversion as well. We were supported well over several million unique IPv6 addresses hitting our infrastructure. We had AXs running in multiple data centers, and there was no infrastructure issues at all. Once again, though, IPv6 traffic was very small traffic overall, but it was actually higher than we expected. So it was very well received, and once again, there was zero support issues related with that. So as you can see here from the little diagram, we were able to support IPv6 users using SLB-PT and NAT to provide IPv6 services to our site. Okay. So with all that said and done, what do you need to do next? Of course, you have to, the biggest part of doing any kind of NAT or IPv4 to IPv6 translation technologies or migration technologies is, of course, test your applications. Usually the biggest testers of this, we have several cable companies and cable certification companies that test products for cable companies and service providers that run all the various applications. But as you know, applications change from day to day and potentially could be unique. So they need to be tested across any network that's running any kind of network translation. And of course, you need to evaluate that impact on the existing infrastructure, performance-wise, capacity-wise, and growth-wise, of course, and ensure that these products are compatible. Of course, there's a certain degree of training that's going to go around, right? I mean, IPv6 addressing structure and routing structure is very different from what they may have been used to on IPv4. One advice is maybe start small by enabling your website to support IPv6 by taking advantage of SLB-PT or one of the conversion technologies, and of course run a pilot. I guess the key here is that significant testing is involved to make sure that all of your applications run totally transparent and your network can handle the added load of doing network address translation on your network. Okay, so a little bit more about A10 networks and what we provide. So here's several of our products, which are our AX series product, which are provide the IPv4 to IPv6 migration technologies. So this is very mature. We have many live deployments in production for everywhere from large service providers and cable providers and cellular providers to enterprise users. We have quite a few marquee customers that we show you. We were actually part of the Interop ShowNet. All of the IPv6 were provided by AX devices. A high performance. So once again, when you're doing this, we need to provide a very high session establishment rate, large number of concurrent connections, very high throughput packets per second. And we have, once again, we have products that range from about 7 gig of throughput all the way up to well over 100 gig of throughput for a various range of customer use. They're in very small, low power form factor from 1U or 2U. And all of our feature set is inclusive. What that means is that whether you use a couple of features or all the features, we do not charge you site licensing. Like our competitors typically will charge you if you add on individual services, or we do not. What makes us unique is what's called our Advanced Core Operating System. And it's currently runs on both 32-bit as well as 64-bit hardware. All of our new products are 64-bit hardware. It's very scalable, which provides very high performance. It's optimized for multi-core CPUs. So whether we use today a combination of various CPU technologies, such as Intel i7, Sandy Bridge, Westmere, various multi-core chip technologies. We also provide what's called a shared memory architecture, which makes us unique, really designed to be very efficient, very high performance, takes a very small amount of space, and very little power consumption. And we also have flexible design. So what that means is that you can scale up very easily and scale down very easily. A10 is in multiple markets. First, the application delivery market. This is more of the server load balancing, and there are competitors, competitors such as like F5 and Citrix, who also provide an application delivery controller. Also within cloud computing and virtualization, so we actually have a virtualized product, we have a virtualized chassis product, and multi-tenancy technologies. And these are, once again, we also compete with the standard application delivery controller vendors. And then right there in the middle, which we spoke about mostly today, was the IPv6 migration technologies, dual stack encapsulation translation. And this we typically compete with the traditional routing vendors, such as Cisco and Juniper and so on. And just to expand upon that a little bit more, you'll notice that we have within the IPv6 migration market, we have kind of two areas: the service provider solutions, which take advantage of large-scale NAT, carrier-grade NAT, NAT 444, dual stack light, 6RD, NAT 6.4, and DNS 6.4. And then on the enterprise side, have more specific needs that take advantage of SLB-PT, SLB-64, and dual stack for IPv4 and IPv6. And all of this rides on our ACOS Advanced Core Operating System platform. It's just a screenshot of some of our most popular clients. We have about 1,800, actually. I think that number is much higher now. Customers worldwide, everyone from Microsoft, KDDI, from service providers to large enterprises, and pretty much everything in between. So once again, just a quick recap, our IPv6 and IPv4 advanced traffic management on our AX series. Our ACOS platform is a high-performance application delivery controller with IPv6 migration technologies for IPv4 preservation. We recommend some links down there for you to read. There's some case studies and some white papers that you can go ahead and take a look at. And with that, that's basically the end of my presentation. I hope you found this useful. Hope you learned something. But once again, if you have any questions, please contact one of the A10 sales representatives that are close to you. And once again, Daniel, I'd like to thank you for allowing me to present. I'll pass it back to you.
Okay, thank you very much, Steve, for your presentation. Yes, indeed, we are now on the questions and answers time. Podéis plantear las preguntas si queréis a Steve. Podéis plantearlas en español, yo trataré de traducírselas, o las podéis plantear directamente en inglés. Recordad que si queréis plantearlas de viva voz, lo cual os recomiendo porque es una forma bastante directa de interpelar a Steve ahora que lo tenemos ahí. No tenéis más que levantar la mano, accionando el botoncito que pone Raise Your Hand. Levanta tu mano, entonces yo os abriré el micrófono y podréis plantear las preguntas directamente. Si no, bueno, pues me las escribís donde pone questions y yo se las trasladaré a Steve. Animaros porque una vez que publicamos el vídeo, pues ahí no podéis hacer preguntas ya. Okay, Steve, while somebody asks you the first question, I would like to ask you about some questions.
Sure.
What is the acceptance of IPv6 in USA? In general, in the corporative sector, but mainly in the carriers industry. What is the acceptance? Are they migrating to the IPv6?
Yes, they are. I mean, they are because they have to. But really, once again, the main reason on the carrier side for them to migrate to IPv6 is strictly IPv4 exhaustion, meaning they're running out of IPv4 addresses and they need to continue to provide for their customers. But once again, they are probably the biggest users of equipment device-wise that do this. But once again, their main reason for them moving that way is really just IPv4 exhaustion, and they need to continue to expand, right? So that's kind of their reasoning behind doing that.
Mm-hmm. Somebody asked me, or asked you, sorry, what are the main problems that you encounter in your migrations? What are the main problems that you are finding in the migrations?
Okay. Some of the main problems that I wouldn't say problems, but just concerns and issues that you run into when you're doing this, probably the biggest one is logging, meaning once you, as a service provider, once you start to migrate to IP using any of these migration technologies, you now have to log those connections so that if you need to keep track of individual users for whatever reason, if the service provider needs to provide to the government entities keeping track of these addresses, that generates a lot of log information. And that log information can take up tons and tons of storage. So one of the technology we developed as we learned that going into this was the ability to take advantage of some of our server load balancing technology, which will distribute and reduce the amount of logging necessary. So for instance, instead of 10 terabytes of logging information, that gets reduced maybe down to 1. So almost 90% reduction in logging. That was one of the biggest concerns. And then on a secondary note, some of the other concerns, which is always a concern, is any kind of new applications, because as you may know, you may or may not know that when you do NATing, any kind of network address translation, certain applications, their behavior is different, right? So one of the ongoing issues that we're always dealing with as a company in developing, and we've done a very good job of this, better than everybody else from what I'm understanding, is that maintaining that significant that very transparent behavior when you're running new applications through a NATed network, right? So I'd say those are probably, there's probably 5 or 6 more others that I'm not mentioning, but those are the 2 major ones that I know of are a continued concern. So we generally, as a company, stay on top of it, and we've done a very good job at making sure we've been totally transparent to new applications and doing a very good job on the logging side.
Mm-hmm. What about the prices? Can you tell us something about or anything about prices of the Prices and license policy of the AX series?
Yes, certainly. So once again, I'm not the salesman, so I'm going to give you a price range for more specific countrywide, but I'll give you in U.S. dollars. So the products range in price from, on our low end, we have a model that does about 10 gig worth of throughput, and that ranges at about, starts at about, say, $30,000, $25,000, $30,000 U.S. dollars, and could go all the way up to, say, $200,000 on our AX5000 series, which is designed to do, you know, basically between 40 and up to 100 gigabit of throughput now. So that's kind of the range for, you know, some of those products obviously on the low end are more geared towards enterprise clients, and of course on the high end, the higher throughput devices, higher cost devices are really designed for more of the carrier service provider customers.
And lastly, I would like to know from your expert point of view, the car makers, now we are hearing a lot about that new cars, they will have each one an IP, a unique IP. I suppose that the car makers are using IPv6 for the new cars, isn't it?
I would believe they would have to, because we just do the mathematics, right? You know, like I said, Aaron's run out of IPv4 addresses. I mean, obviously car makers, they're big companies, so they could probably buy addresses, but it would make more sense to them with the amount of cars that are on the planet for them to use IPv6 just to handle a number of addresses that they would have to supply, right? So yeah, in their case, it would make no sense to use IPv4. It would only make sense for them to use IPv6, and hence, once again, if that occurs, and it is occurring now, that's going to add a whole bunch of other new applications and technology that is now running across the existing, you know, IPv4 infrastructure, right? So there's these type of, the service providers will, once again, the service providers that are making the connection between the cars and the back-end networks will have to now expand upon their IPv4 migration infrastructure, right? So
okay.
It just means more and more growth, basically, is the answer.
Okay, we have some Brazilian person from Brazil assisting this webinar. I don't know if you can, and of course we have Spaniards also. I don't know if you can give us a shot about your presence in Brazil and Spain. Do you have office in Brazil and Spain?
We do. I don't know specifically what towns they're in, but I could do a quick check on our website. I believe we have offices like in São Paulo, and I'm not exactly sure if what their physical locations are. I'm in marketing, I'm not in sales, but I know we have presence in both Brazil and Spain. So.
Okay, Steve.
I mean, basically, I believe if you go to our website, you can actually, there's usually a general contact, and we can get you the more specifics as to where exactly they are and how to contact them.
Okay, Steve. So good morning to New York. It was a pleasure to hear you.
Well, thank you and gracias.
Gracias, muchas gracias. Thank you. Muchas gracias y esperamos veros tanto a la audiencia como a los ponentes por aquí en breve. Recordar, el webinar se ha grabado íntegramente y lo publicaremos pues en apenas un par de horas en demosdesoftware.com. Demosdesoftware.com es donde publicamos todos nuestros vídeos y los podréis ver con capítulos tranquilamente y si queréis desde un iPad o desde un tablet Android. Un saludo a todos. Seguir atentos a tecnowebinars.com y a nuestra red de portales porque hay muchos webinars que os pueden interesar. Un saludo. Hasta luego.